Yeah. Okay, maybe in the meantime, you can download the files for the presentation. If you go to the EuroPython schedule, that's not EuroPython.org. Excellent. If you go to the EuroPython schedule and click on the training, on the title, there is a URL at the bottom where you can download the files for the tutorial. Maybe I will make it bigger. Okay, you can just type it to. Okay, I will start. So, welcome everybody to the hands-on Pygame tutorial. My name is Radomir Dopieralski, and I work for the Allegro group. I work with the system administrators to create tools for system administration, obviously. And I know Pygame as long as I know Python, because I used Pygame to teach myself Python, because it's a great motivation. You know, you can write your own game, and that's an excellent way to learn a language. I come from the roguelike community, so my first game was a roguelike game. It's a kind of dungeon exploration game. But today we will try to write something like this. It's a top-down, turn-based, tile-based, I wouldn't say it's a game, it's a technology demo. We will try to explore Pygame and see what's strong and what weak points it has, and what patterns work best with it. And at the end, you will have a nice seed of a game that you can use to extend it and to build your own game. I won't tell you about game design here. I'm only concerned with game programming, because game design is such a huge field that I don't think 4 hours would be enough just for the introduction to game design. So you're on your own here. The training will take 4 hours. There will be a 15-minute break in the middle for the coffee, but we will have 3 short breaks in the middle of it, so that when we finish one part of it, we can get a rest. It's divided, well, it's organized in such a way that we start with very basic things, then go through the moderate, and at the end we will talk about some advanced topics. So if you are bored at the beginning, you can just leave and come back after a while. If you have any problems, anything doesn't work, you don't understand something I'm showing, ask questions immediately. We will try to help you immediately, and so that you can we can work together, not having anybody left out. Okay, all the graphics that I'm using, well, all the graphics that the game uses, because there are some example graphics from different games, but all the graphics that I'm using are from the Liberated Pixel Cup contest. This is a contest that started a month ago, and it's for creating game art that is free to use for game developers. It's Creative Commons Attribution license. the first part of the contest was creating the artwork. Now, yesterday started the second part of the contest, which is reading the game. And my intention in making this tutorial is to encourage you to take part in this contest. So you will end up with something that kind of works, and you can build your game on top of that. So it's a great opportunity to enter the contest. We will start with the first program. Do you all have the files downloaded? If not, okay, I will show you the URL. Please download this file, you will need it. Please unpack it and because I have some code on the slides that I will be showing, but you will need to run the examples and you will need to look at them in your own editor, otherwise you won't learn. So please download this file. Who doesn't have the files yet? Okay, we will wait some more. If you have any problems, just say I will come and help. Okay, who doesn't have it yet? Okay, I think I will start if you still downloading. Okay, the first program is very simple. We will just initialize Pygame. Well, we will do what's written in here, so I won't repeat that. And we have, if you go to the 000/000.py from the files that you just downloaded, you will see something like that, just with docstrings. I stripped docstrings here. This is the basic structure we will use for our program. And there is another question: how many of you could write this program right now without any problem? Okay. Excellent. How many of you have programmed anything game-related before? And with Python? Okay. That will be easy. Can you tell those people where to get the files? Or you can just down hit this pen drive. This one. The pygame.zip. Okay. So we will try to fill this in. In this tutorial, you won't be writing any code of your own because it would take too long. Sorry about that. I know it's not very good for learning, but well, we are short for time, so we will start with initializing the screen. In Pygame, well, you have to initialize Pygame itself, or at least the parts that you are going to use. We are going to use only the display part. We are not going to have any sounds or anything like that. So we just initialize the display. And we will return the screen surface that we got back. It's the surface of the window that we have. Surface is a very basic, very important concept in Pygame. It's basically a grid of pixels. It's basically an image in the memory. And almost everything we will do with Pygame is done with surfaces. The screen itself, the window, the Pygame window, or the screen if it's in full screen, is a surface, and all the sprites, all the backgrounds, everything we do in our game are surfaces too. We can create an empty surface with the Pygame.surface constructor, and it has a number of useful methods that we can use for filling it with a solid color, for bleeding another surface on it. And bleeding is the most common operation we will do. It's basically the core thing that all 2D games, at least in the 80s and 90s, do. Bleeding surface on another surface is like stamping it on it. So we take a surface and we basically draw it on another surface in the place we specify by destination. And the result is that the original surface is modified, now has this other surface painted on it. And this operation is destructive in the sense that you cannot undo it. It doesn't remember where those pixels came from, so we'll have to remember it for it. So once we have the surface, we will need to once we have the window open, we will need to wait for the window to be closed by the user. Otherwise, our program will end immediately, and we always will see a window appearing and disappearing immediately. So this is a simple way to wait for the window to close. We have an infinite loop. And in that loop, we are taking events from Pygame event queue, and we are using the wait function. So we are blocking until we get an event. And then if the event type is the quit, that means that the user clicked on the X on the window, has closed the window, then we'll just return. This way, this function just waits for user input. If you open the 00001.py file, you can see all this code. There are basically two ways to get events from Pygame. We can wait for them, or we can just try to get whatever is on the top of the queue. This function, this method will return a single event. This can return a list of events or an empty list if there are no events waiting. The difference is this one doesn't block. So we will see later how that is useful. And there are different kinds of events. There is the quit event that we just used. There is the key down and key up event that handle keyboard. There is the mouse motion and mouse button events that handle mouse. There are more of them. There are events for joystick, there are events for, I don't know, window being resized, things like that. We will get to that. So this is the way we get input from the user. Okay, you can try to run this 001.py, but you will not see anything. You will see a black window. That's because even though we filled we have filled our surface with a gray color. In Pygame, colors are represented by tuples of numbers. So it's convenient to use hex numbers in this case. So it's normal RGB 666666. It's gray, right? So you will not see anything. That's because even though we painted on the surface, we didn't update it. Every time we do something on the screen surface, it's only in the memory, and we have to call up this Pygame display update to have Pygame copied to the graphic card. So, and this is quite a slow operation actually. That's why Pygame is pretty slow. It does everything in CPU. It's not accelerated. But well, if you run 0.0.2.py, you will see that we have a gray screen now. Yes. Well, you asked if you can use normal integers instead of hexagonal colors. Yes, those are normal numbers. They just it's convenient to write them that way. Okay, so we have our gray screen. Now we want to have a picture in the middle of that screen. So, first we need to load the image into memory. We do that with pygame.image.load. If you open the 003.py, you can see the full code for that. Oh, if anybody of you runs the example and it doesn't work in some way, please raise your hand and we will see what's happening there. It doesn't work? Okay, that means you have Pygame compiled without PNG support. Did you compile it yourself? Okay, can you make sure that you have libpng installed and compile it again? Thank you. Well, sometimes Pygame is a little bit tricky if you compile it yourself. So this should draw the... Okay, so we load the image into the memory, and we have a surface here. And then we can bleed that surface at 0, 0, that means the upper left corner. In Pygame, all the coordinates are counted from the upper left corner, the same way that the memory is addressed in the graphics memory. That may be intuitive for mathematicians, where you have usually the 0, 0 is on the bottom left, but that's how computer graphics do it, usually. Okay, so if you open 004.py, we have some more advanced thing in here. The first thing, after loading the image, we convert it to the same bit format as the screen surface. That's an optimization to make it faster. We will later always convert any images we load, so that's you don't have to know exactly what it does. It just makes sure the formats of the screen surface and the image surface are compatible with itself, so it doesn't have to convert them each time you do a bleed. Then we do set color key. You have noticed that there is this ugly pink background on the image. and we want that background to be transparent. So with setColorKey, we can tell Pygame which color should be treated as transparent. In this case, this is the magenta, so it's FF00FF. I use magenta because there is a very little chance I have this color somewhere on my image that I wouldn't want to be transparent. And then we take the rectangle of the screen, and rectangle is another core concept in Pygame. It basically represents a rectangle. Well, the coordinates and the width and height of a rectangle. There are three ways of creating a rect object. You can specify the top and left coordinates and then width and height. You can do it with tuples, or you can make a rectangle from another rectangle, basically. And once you have it, and anywhere in Pygame where Pygame expects a rectangle, you can just give a tuple directly. You don't have to create rect objects all the time. But if you have a rect object, it has a number of very useful properties on it that you can use to calculate. For example, if you want to know where is the center of the rectangle, you just do rect.center and you will get the center. So we will take the rectangles of the screen and of the image, and then we will bleed it not in the top left corner, but we will calculate where is the center of the screen. Basically, we take the width of the screen and the width of the rectangle and divide it by 2, so it's kind of aligns the right way. Okay, but that's kind of complicated way to write it, and you can easily make an error and have your image drawn out of the screen or something like that. It's complicated and it's hard to debug. So we will use this method of this property of the rectangles, and if you look at 005.py, it does exactly the same thing, but it's, instead of doing these calculations, it just assigns the image center to the screen center, because those properties are read-write. And the rectangle will move to match this. And then we can bleed to that place. Okay, that's the end of the first part. Is anybody still having some problems? You are still compiling, right? Oh, okay, that's great. So, do you want to make a break now so that you can breathe a little, or do we continue? Because this is kind of small part. Who wants a break? Okay. Then we will continue. Okay? Okay. Can you open the PNG file? Podgląd. Nie ma teraz żadnego graficznego. Co w ogóle już? Chyba twój Mac nie bardzo potrafi otwierać pliki PNG. One moment. Wiesz co, to samo? Wiesz co, no na wszystkich innych platformach to działa. Na moim Macu to też działało, bo też to testowałem na Macu. Na Lionie. Więc no trudno mi powiedzieć. Jakbyś... Okay, so there seems to be a problem with the transparency on Macs because the color key, this doesn't seem to work with the PNG image that I provided. At least some people still see the pink background in there. I'm not sure what's the problem exactly. So we will just continue and I will try to figure that out later. So I hope we will manage to solve that. Anyways. Okay, so the PNG file is somehow strange. Yeah, just open it in some graphics editor and save it back and it should be okay, but I'm afraid this may happen with all the PNG files that I provided, so... Anyways, we will now try to do something more involved, something more interactive, and something that looks more like a game. We will do this. If you go to 001/00.py, we basically add two methods in there. We will have all the images we will use loaded into a dictionary, and we already do the convert thing, so that it's fast. Actually, it doesn't help that much, but it's good habit to always do the convert. And then we will try to draw our map. There is a huge list of strings in that file that defines how the map should look like. And we will just iterate over lines over the list and then over the characters in the lines, and we will try to draw the dirt PNG image all over the screen. I will show you how it works. Okay, you should get something like that. Anybody who doesn't have that, raise your hand. Oh, they are in the same directory as the files. Okay. Now, once we have our screen filled with dirt, we can proceed to trying to fill it with something more meaningful. The only difference is that now we use the character that we read from our map definition to choose which image to draw. And the result should be something like that. Okay, you can see that we use enumerate. You may not be, if you are starting with Python, you might be not familiar with enumerate. Enumerate is a very nice way of iterating over something, over any list or iterable. It basically gives you tuples of the index and the value. So it's nice idiom. Okay, now we will change our wait for quit method to actually read the key presses from the user and to display something on the map so we can walk through this maze. If you open the 002.py, there is another thing that's kind of advanced Python. We have a list comprehension here. A list comprehension basically turns our list of strings into a list of lists. We need that because strings are immutable. We cannot modify the strings in place. And we are modifying our map in place by placing the player character on the map. So, and then we are drawing the map like we did previously. And we are just waiting for the window to close, like we did. Okay, you should see, because we start with 1, you should see a small face in the upper left corner of the maze if you run this. And then we add checking for what key is pressed, so that we can move that character around. If you open 003.py, you can see that instead, apart from waiting for the windows to be closed, we also check for key down events. And well, if it's escape, we also quit the game. And if it's an arrow key, we'll just move the hero appropriately. And you can see that we are on every round we are deleting the hero with the dirt, and well, first we are drawing it, then we are drawing the map, then we are deleting it. So when we move, we can we don't have duplicated heroes, we just have one. But if you run this, you can see that you can dig through walls. That's actually pretty cool, and it could be a game of itself. That was 3? Yeah, we can jump on the walls. So it's kind of a game already. But we don't want that, especially since we can leave our map and crash the game, or wrap here. That's not very good. So we will move our hero moving code to a separate method so that we can customize it better. so far this, and we will make a check and only allow moving the hero if the map contains dirt. One thing, because we have lines in our map, and the lines are lists of characters, then we always index Y first and X second. This is something we will have to get used to, because it's organized that way, but we can later show how to change that. And if you open 004, you can see that you can no longer erase the walls of the maze. Okay, and so far our games have very simple code structure. There are just functions, right? There are no methods. I used the word methods, but that was incorrect. That's just because I'm used to that. And we would like to have some objects, so we have object-oriented programming in Pygame. Python is an object-oriented language after all. So we will think about what do we want to turn into objects. What parts of that we have already in our game deserve to be an object. Because if we do too much, for example, we could make every map tile could be an object. But that's, okay, let's think what attributes that objects would have. It would have the tile type, of course. Is it dirt, or is it wall, or is it the player? And that's it, right? It could have the position, but position is not something that belongs to the tile, it's something that belongs to the map. So that's not it. It could have, I don't know, some methods to check if it's blocked or not, and things like that. But again, that's better checked with the hero. We can have the hero, but right now the hero is just another tile, right? So that kind of doesn't make sense. We will definitely need an object for the map, because this is a nice solid object that has access methods, and that we can load from the disk or something like that. So map is definitely a good object. And because we don't like global variables everywhere, we will have an object for our game. So that's the object that encapsulated all of the game, so that we can have all our variables inside that object and not as globals. So if you open 005.py, you can see the level object. It basically uses the same code that was there, except for the set item and get item methods, which basically let us use x comma y instead of using yx. They basically change the way that the square brackets work. And we have the render method that just paints the map on the screen, and our move hero method that lets us move the hero. We can see that hero position is part of the level, because hero itself doesn't know its position. It only has position on the map. So it's logical to have the map keep track of the position of our hero. The game object, if you look at 006.py, it doesn't fit on the screen. But basically we have our initialization. We have one change. Instead of using if, elif, 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 elif with the keys that we use, we have this dictionary that tells us that when the user presses key up, call the method moveHero with those parameters. And later, we have the moveHero, we have the quit, and this is the control loop that actually does that. It takes the event and it checks what key was pressed, takes this, selects this action, and then calls that method in maybe that's not very understandable way, but basically it takes the first element of the tuple, so this is the first element, and calls it as a function with the rest of the tuple. Okay, the display method basically just renders the level and updates the screen, and the run method is what is our main loop. Are there any questions? Because this is a large jump and it may be. Yes, we will get to that. Well, you have to handle it yourself. There is a key down and key up event, so you would need to have a loop that until the starts when you press key down and repeats the key until it gets the key up event. But we will do it in a better way later, so just be patient. I'm supposed to repeat the question. So the question was about the key repeat, so that we can hold down the key and have the character moving on the screen. Okay, now we will explain about tiles. I don't know if you can see it, but it's a screenshot from the Seiken Densetsu 2 game. This is a game that I personally think that has amazing graphics, and this graphics it's not immediately obvious that it's composed of tiles. I will highlight the tiles for you. First of all, there are layers. So every color shows a different layer of graphics, and then there are repeating images. The whole screen is composed of repeating images. I highlighted with colors where the same images appear. Well, some of them don't look the same because there is another layer on top of them covering them, but basically you have square elements of the screen, and they are all taken from a sprite sheet. Or tile sheet. Tile sheet looks something like this, and in the game you select fragments of that and paint it on the screen, just the way we used our dirt.png and ground and wall.png. Now we will just use parts of this image. We will also use sprites. If you look at this screenshot, you see that the characters here are not fitting the sprites, right? The map. They are not composed of those tiles. There are separate objects that are drawn on top of the map, and they are called sprites. And for the sprites, sprites are usually animated, so we will also use sprite sheet, and we will draw one frame from it, and then we will change it to animate it. Okay, if you go to 002.py and 000.py, you will see the function we will use for loading the sprite sheet. It basically loads the image sets the color key and all that, and then it will iterate over all the image and will cut out small pieces of it, creating subsurfaces. Subsurface is a kind of Pygame surface that shares data with another surface. But it can be smaller, and it can have different transparency, and it can have different color key, and it can have different all the attributes, but it has the same data in memory. So when we create all those subsurfaces, we don't use more memory than already the images use. So that's a useful way of having another copy of part of the image. And we will put all those images on the list and return that so that we can refer to them. Okay, if you run this example, 002. Okay. If you run the example, you will see all the tiles loaded and displayed with numbers on them. By the way, in the code you can see an example of how to make text in Pygame, and even a text with a black frame around it. There is a trick to that, but I won't get into it right now. If you see at the tilesheet.png file and compare it with what we got from our example, you can see it's all the same. Actually, we will use that example because it's useful to see which number corresponds to which tile. Okay. Once we have tiles, we can change our level to include layers. So we don't only have one layer of graphics like we did in the previous example, but instead we will have several layers. And basically we again copy the strings because we want them to be well, let me just take the code, it will be easier to explain. Okay, right now we have a list of layers that only have one layer, and we have a dictionary of tiles. And the dictionary of tiles tells us which character means which tile in our list of tiles. Then when we convert when we read this list of layers into the actual map, we can just use those numbers directly here. So we are basically converting those strings into lists of numbers. And later we can use those numbers directly to just bleed the tiles from our tile sheet that we have loaded. So when we run this, we will have something like this. It's not very pretty. It's basically the same thing that we had before. So let's add another layer. 002.py basically only changes, only adds another layer and adds some more definitions for the tiles. You can see it's not very readable, but oh well. And if you run it, you can see that it looks much better now. We can actually use those edge tiles that show you that make it look really awesome. But as you noticed, it's very inconvenient to actually draw them up this way. That's why we will use a map editor. There is we will use Tiled. Tiled is a nicely written map editor written in Qt, available at mapeditor.org. You don't have to install it now because I have prepared several maps that we can use, but you will probably want to have it when you are doing your own games. It's very convenient. It looks like this. And we can open some map. Okay, and we can just select the tiles we want and paint. Yeah, it's really much more convenient than reading all those letters. So we will use that. It has, as you can see, it has layers that you can use. You can disable them and enable them. And it can also add objects to there. We will see that later. And it actually saves the map that you are making in an XML format. But there are a lot of libraries, of ready-made libraries that you can use to read that. So you don't have to parse XML yourself. Never parse XML yourself. XML is not for people. Okay, that's it. And we will use TMX loader library that is included. You can see the PyTMX directory in there. That's the library. It's pure Python, so we don't really need to install anything. We can just include it with our game. And it's LGPL, I think, so we are free to use it. And okay, so we load our map with this loader, and we have to change our render function to actually use this map we have loaded. This loader also loads the images automatically, so we don't have to use that load sheet function anymore. We have this get tile image method that we will use here. It takes the X, Y, and layer. So we iterate over all the layers, we iterate over X, we iterate over Y, we iterate over X, we get the image and we draw it. and that's all. The W and H are the size of the tile, so we can have it, and if you run it, you can see our pretty map in there. You can use more tiles and more kinds of tiles to make it even nicer. So now that you have editor, you don't really need to touch any code to change it. Sorry, how much time do we have? Oh, I don't read that. Okay. Yes?
Basically what you did, you map it into you play with it, with the tiles, you implemented it, you saved it as a TMX file.
Yes.
TMX parse this text-based file, implemented it, just shoved it into Pygame.
Exactly. Yeah. So it's really great to use libraries because they save you a lot of headaches, and usually you don't have to fix the bugs in them. The author fixes the bugs. So because reading a game is such a huge task, it's really nice to have libraries and to use them. It's not the university. You are not required to write everything by yourself. Yes? This is strange. What version of Python is this? 2.6. Do you have Python 2.7?
No, it's in company web.
I see. It may be possible that, because I didn't test it with 2.6. That sucks because you won't be able to run any further examples because they all use that.
Okay, I try to fix it.
You basically it uses the element tree for parsing a tree. I think it's a tree or something like that. Element tree. Yeah. Okay, once we have our map loaded, we will add the hero here, and we use the same code that we have previously. The only change is that we don't change the map directly. Instead, we will just draw our hero on top of the map at the end. When we finish drawing the map, we will draw the hero. This way, we don't have to replace every tile that the hero has visited with dirt anymore. Okay. And now we need a way of checking if the tile is blocked or if the hero can pass through it. And the usual way that you do it with tiled is to have a control layer where you have tiles that just mark the areas that are unpassable, that are blocking. And I have a special set of tiles for that, and the tiles themselves have properties, and I have set the property block to 1 on those tiles, so that in the code I can check for property, and if if a tile has property block, then I say that this tile is blocked and you cannot move here. That's the way I checked. I check if the tile is blocked or not. If you run it, you can see that you cannot step on the grass anymore. Okay, now we will introduce sprites. You can notice that here we are drawing the hero character on the map, but we are drawing all the map and then the hero character, and on the next turn we are again drawing all the map and the hero character, and that's kind of inefficient. What we can do is instead draw the map once, draw the hero character, and somehow move that hero character over the map. How we do it is we remember what was on the map behind the hero, then draw the hero, then when we want to move him, we draw what was there before and we paint the hero in the new place. And Pygame has a mechanism for making that easier. It's called sprites. And what's nice about it is it will keep track of where the hero character was before. So it will automatically clear it for us. There are two basic classes that we will need. The sprite class, which basically holds the image and the position on the screen, and the sprite group class, which is a convenience for holding many sprites in one place and for drawing them all at once. We will use the render updates sprite group, which has some additional useful methods on it. Okay, I propose that we make a short break now, and in half an hour, right? There is a coffee break. Oh, in 20 minutes. Okay, so let's make a 5-minute break now, and I will explain about sprites after that. So, who came new here and doesn't have all the files? Raise your hand. Who just came? Okay. Do you have this pen drive? Okay. Okay. Can you copy the pygame.zip from here? You will need those files. Yes? Oh, do you have the same problem? Yeah. Yeah, yeah. Yeah.
I get some attribute error is available, should be available. No, I'm on 2.6 at the moment. So, yeah.
Yeah, you can try and correct that in PyTMX to change that. That's strange. Well, that's a bug in the library. You can try installing element 3. We'll just do pip install element 3 and maybe it will help.
Is it E3 or element 3?
Any of them should work. Try now. The same. I didn't test it with Python 2.6. I wrote that Python 2.7 should be used, but it's a bug in this library. Is in that library. Great. Okay. I just have Python 2.7. Yeah. Okay. Sorry. So, yeah. Can you copy it? It's pygame.zip. Okay, I will leave it. Okay, everyone, I think we can proceed. Or do you need some more time? No answer? Yeah. Maybe you could install Python 2.7, maybe in opt or something like that. So the library for PyTMX that we are using doesn't work on Python 2.6. It only works on Python 2.7. That we just discovered. But well, I will report that to the author, and I'm sure he will fix it. Anyways, so the sprite has three important things on it. It has the image that is used to display the sprite. The rect attribute tells how large the sprite is and where it is on the screen. And there is an update function that we can override ourselves, that we can call on every turn to update the sprite, for example, to change the frame of animation. And the sprite group has three important methods. There is the draw method that will just draw all the sprites in the group on the screen. There is the clear method that takes an additional surface that keeps the background, and it will draw the background on all places where sprites have been. So it will erase them. And there is the update function that just calls update for every sprite. Okay, so we will define the sprite for our hero, and we always need to, because the sprite class has an init method that does important stuff, we always have to call it. We always have to call the init of the superclass for the sprites. And we just load our sprite sheet and set the image of our sprite to the front-facing frame of our sprite sheet, and we will set the rectangle of the sprite to the rectangle of the image because it's the same size, right? And we will move the rectangle to the right place. This is the 32 is the size of our tiles, 16 because we want the middle of the tile, and 32 again because we want the bottom middle of the tile. So we will set the mid-bottom point of the rectangle with the middle bottom of the tile on which it stands. Okay. When we move, we will just move by increments of 32 pixels. And okay, we will create that sprite in the game and we add it to the sprite group. And we will need the background with which we will delete the sprites. So we just copy the screen surface, we will make a copy of it and use that as the background. We will render our map on the background, not on the screen, so that we have in memory a separate image with the map. And then we will bleed that image on the screen so that it's nicely displayed. But later, when we display, we will use this background to clear the sprites. So on every turn we clear the sprites, we update them, and we draw them. Okay, and one more thing. When we draw the sprites, the draw function returns a list of rectangles where the sprites are and where the sprites were. And then we can use that to only update parts of the screen, not the whole screen every time. This is much faster because the computer needs to transfer much less data to the graphics card. It only tells the graphics card what changed. So it's called dirty rectangles, so we have this dirty list, and we will pass this to update function so that it only updates those places. Okay, and we have changed the move hero method to actually move the sprites instead of moving instead of changing the map. Yes, actually it's two sets. The rectangles that contain new sprites and the rectangles where the sprites were and were erased. So it's kind of concatenation of the two lists. Okay, and if you run that, you can see that we have almost a professional game now. We have this guy running around. But the guy is kind of boring and he only jumps around with large jumps, and we would like to animate him so that he really moves his feet when he walks and so on. So to do animations, we cannot wait for the key press anymore, because we want to do animations while we are waiting for the key press, right? So we will, instead of doing pygame event.wait, we will do for event in pygame event.get. That loop will loop for all the events that are available in the queue. And well, the rest is the same. Okay. And because now we are not waiting, the game would take 100% CPU, because it would redraft the screen all the time. To avoid that, we will use a clock. We create a new clock, that's pygame.time.clock, and it keeps track of time, so that when we call clock.tick with 30, it makes sure that it blocks, it waits, so that we are never calling it faster than 30 times per second. So we are limiting our game to 30 frames per second right now. This is the clock. Oh, and if you need to keep track of how much time you waited, it also returns the milliseconds that it waited. So that may be useful if you're making any physics simulator or anything like that and you want to integrate over time. Anyways, we have, well, that change didn't really change anything in the game itself. It still should play the same. But if you go to 003 /001.py and run that, you will notice that there is animation. Okay. 001. There is animation already. Our guy is sliding. Okay, that looks kind of silly, but it's already an improvement. So what we want to do is change the frames of the sprite to make him move his feet when he's sliding, because the sliding is kind of not enough. So to do that, we will use a trick that I like to use. We will have an animations list on the sprite, and different kinds of moves, different kinds of things that happen to the sprite will add different animations to that list. And an animation will be an iterator generator. An iterator generator is basically a function that you can call in parts. So, as you can see, if I make it's any function that has the yield keyword in it, and it basically executes to the first yield when you call next. It executes to the first yield, and next time you call next, it starts from where it stopped and executes to the next one and to the next one. And when there is no more yields in it, it will rise stop iteration exception. And we use that in the update function. So we basically call the first animation on the list and call it next. It does something and does yield. And when it finishes, we remove it from the list, and then we can, next time we will call the next animation. This time we can write animations in very comfortable way. We don't have to do, okay, if the current frame is 3, then do something like that, or otherwise if the current frame is 8, then do something like that. Instead we can just tell what to do in order of what's happening. That's very convenient. In here we are just moving the rectangle of the sprite by 4 times the direction in which we are moving, right? And if you run this, you have the same sliding animation that you had. But we can add facing. Basically, we have a dictionary of different facings. If you look at the code 002.py, and depending on what facing we have on the sprite, we select a different image for the sprite. They are in the same order in the image file that they are in the dictionary, so we can, if we run it, we can see that it's still sliding, but at least it's rotating. So we can have a skiing game, or maybe. Anyways, now we can do better. Instead of just changing the image depending on the direction, we can change it depending on the what step of the animation we have right now. So basically we have the facing, and step is multiplied by 4 because the sprite sheet has 4 different facings. Maybe I will show it. It will be more understandable. Okay, this is our sprite sheet. In the beginning, we just used the first sprite of every of them, right? And now, depending on which step we use, we will use additional ones. So we have a walking guy. Maybe a little too quick, but well, you can tweak the frames per second parameter to have it differently. Okay, now there is the question that you asked. We would like him to keep moving when we keep pressing the key, because now it really looks awkward. Okay, and we will do that after the coffee break. So, thank you.